Hi everybody, we are going to solve paper 4, year 23, May, June, version 1. First question, straight section of river where water is flowing right to left at speed 0.54 and the swimmer starts at point B, swims at a constant speed 0.72 meter per second relative to water and at right angles to the current. Determine relative to the river bank, which is the horizontal direction, exactly like the current, both magnitude and direction of swimmer's velocity. So we have to draw the vectors. Current is in horizontal direction with magnitude 0.54 meter per second, and the swimmer from point B is in the vertical direction with magnitude 0.72 meter per second. Then the magnitude of the resultant velocity will be in the direction that closes the triangle, okay? And its magnitude, the magnitude of the resultant will be square root of 0.54 squared plus 0.72 squared, which will equal 0.9 meter per second. Then the direction of velocity, if we look here and call this angle theta, so tan theta will equal opposite on neighbor 0.54 over 0.72, okay? Then theta equals tan minus 1, this ratio, which is equal 37 degrees. But he said determine relative to the river bank, which is relative to the horizontal, which means he needs this angle, okay? So this angle will be 90 degrees minus the angle theta, which is 37 degrees. So the final answer is 53 degrees. Okay. Calculate distance between B and Q. Q is the point that the swimmer reach after 1.5 minutes. We know that velocity is equal to distance over time, which means that distance is equal to velocity times the time. Here, velocity is not 0.72, it was the velocity of the swimmer in the vertical direction, but because of the current, the velocity takes a resultant vector in the direction that we have just calculated. So we will use the magnitude of the resultant velocity, not the vertical component of the velocity. So distance will equal 0.9 times time, 1.5 minute times 60 to convert it to seconds, and it will equals to use your calculator. 81 meter. When swimmer is crossing the river, his actions produce a constant forward force on his body. Explain why he moves at constant speed. As he moves at constant speed, this means that no resultant force, which is also means that water resistance or friction is equal to his force. Okay, swimmer force. Question number 2, we have a motorcyclist accelerating along a straight horizontal section of track, and the cyclist with the motor have a mass of 240 kilograms. On a straight horizontal section of track, motorcyclist accelerates from rest to 7.2 meters per second square. Motorcyclist reaches the end of straight section of track in 5.3 seconds. Calculate the speed of motorcyclists at the end of straight section. We know that acceleration is delta V over LT. Okay, so V minus V final minus 0, because he starts from rest, over T is equal to A. So V F is equal to A times T, which is equal to 7.2 times 5.3. Answer is 38 meters per second. Calculate the resultant force on motorcyclist and motorcycle on the straight section of track. We know that the force is equal to mass times acceleration. Mass is the mass of both motorcyclist and motorcycle, which was given in the question to be 240. So 240 times the acceleration, which is speeds up with, so answer will be 1700 Newton. At the end of straight section, the track remains horizontal but bends to right. When the motorcyclist reaches the bend, she travels around the bend in a circular path at a constant speed. Velocity is a vector quantity. Show how vector quantity differs from scalar quantity. Certainly, vector has magnitude and direction, but scalar has magnitude only. Describe what happens to velocity of motorcyclist as she travels around the bend at constant speed. Moving in circle, only direction of velocity changes. Explain why there must be a resultant force on motorcyclist as she travels around the bend. Because change in direction needs force, okay, and cyclist changes direction in the bend. Okay. Question 3. Rubber balloon inflated with helium and sealed so that no helium escapes. The balloon is positioned immediately below ceiling of a room. Heaters are switched on and temperature of air in room increases. When the heaters are first switched on, the temperature of air immediately below the ceiling increases more quickly than the temperature of air in rest of room. Explain why this happens. Because warm air is less dense and rise up, while cool air is more dense and falls down. The temperature of helium in balloon increases as the rubber stretches. The volume occupied by the helium increases. State what happens to motion of helium particles as the temperature increases. We know that kinetic energy of particles will increase according to the kinetic model, and hence the velocity will increase, which means particles moves faster. As the rubber stretches and the volume of helium increases, the pressure of helium remains constant. Explain in terms of particles of helium how pressure of helium remains constant. We know as temperature increase, kinetic energy of particles increase. So collisions between particles increase and the change in momentum increase. So the force increase as force equal to rate of change of momentum, and pressure will be constant because area is also increased when stretching. Okay, and pressure is equal to force over area. So if force increase and area increase, pressure remains constant. Okay. A student investigates the efficiency of a filament lamp and the bulb immersed in water in a beaker. Reading on thermometer was 19 Celsius. Glass lamp is in contact with water and the electrical connection are completely insulated and the lamp is switched on. At the end of the experiment, temperature of water is 21.5 degrees Celsius. If you have the mass of water in a beaker 600 grams, specific heat of water 4200 joule per kilogram degrees Celsius, show that increase in internal energy of water is equal to this number. Okay, internal energy increase is equal to the heat supplied to the water, Q, which is equal to MC delta T, which is equal to 600 times 10 to the power minus 3 to convert a gram to kilogram times 4200 times 21.5 minus 19. Use your calculator, you will find this result. Okay. In the experiment, the lamp switched on for 500 seconds. Power supply to filament is 13 watt. Useful energy from lamp is transferred as light. Energy increases the temperature of water is wasted. What is the maximum possible efficiency of a filament lamp? We know that efficiency in percentage is equal to input energy minus wasted energy over input energy times 100. This numerator can be replaced with useful energy. Here, useful energy cannot be determined. It is light and we don't know how to calculate, so we will calculate the input minus the waste. Input energy is equal to input power times time, which is equal 13 times 500 seconds, which is equal to 6,500. So efficiency would be 6,500 minus 6,300, which we proved in previous step, okay, over 6,500 times 100. Use your calculator. So will equal 3.1. Efficiency of lamp is less than the value determined in I, which is 3.1. Suggest one reason for this. If you look to the setup of this experiment, you will find that the heat produced by lamp not only goes to water, it also goes to the beaker, okay, and the beaker is in open surroundings, so it cools down by losing heat to the surrounding, okay. So I would choose one possible source for losing energy, which we haven't calculated in the previous steps, and this source is losing heat to beaker. Question 5, we have a block with this shape where we have a curved surface AB and three straight sides BC, CD, and DA. Two right angles at C and D. Curved side is 1/4 of circumference of a circle that has a center at B. State what is a ray of monochromatic light enters the block through the curved side and strikes the side BC at B, which is at the center of the curve. Some light emerges into air and some is reflected. Here is the refracted and here is reflected. State what is meant by monochromatic. Monochromatic means single frequency light. Explain why the ray of light do not change direction when it enters the block through the side A, B, because it enters normal to the surface. So it goes without change in direction, enters normal or perpendicular to surface AB. Okay. Show that the critical angle C for glass of refractive index 1.5 is 42 degree. We know equation is N, refractive index, is 1 over sine C, which means sine C is 1 over N. C equals sine minus 1 over N, which is 1 over 1.5. Use your calculator. It will equal 41.8 or 42 degrees. Okay. Shows angle between ray of light and line AB is theta. Between the ray and line AB is theta. Okay. where line EB is at right angles to BC. Okay, right angle. Angle theta increases to 45 degrees. State and explain what happens to light that strikes B. Okay, we have just calculated that critical angle of glass is 42 degrees. So when light enters at angle more than 42 degrees, which is the case that we are going to deal with, 45 degrees, means that we have our ray like this. So the angle is greater than C, so there will be total internal reflection, which means that there will not be any more refracted light. All will be reflected, okay, and will be reflected with same angle. So this is 45 and this angle will also be 45 degrees, okay. So we'll answer this question that light strikes at B all reflected, no refraction, okay. And why this? Because angle of incidence I is greater than C. When theta is equal to 45, reflected light strikes the side CD. That's okay. What is required? Describe what happens when this reflected light strikes CD. You should here look for the geometry. This is 45 degrees, this angle. So this angle will also be 45 degrees, okay. And if we draw normal here, we will see that this angle also is 45 degrees, which means that the incidence angle of the ray that is totally reflected at B and incident on surface CD, interface between glass and air, incident with angle 45 degrees, which is again greater than the 42, which is the critical angle of the glass. So there will be total internal reflection inside the glass once again. Okay, so we can answer this question that there will be total internal reflection or all light reflected inside the glass. Okay, a mobile phone cell phone network uses microwave of frequency 1.9 times 10 to the power 9 Hz to transmit and receive signals. Speed of microwave in air is 3.0 times 10 to the power 8, which is C, and it's the same speed for all the EM spectrum. Calculate wavelengths of this microwave in air. We know V equals lambda times F, so lambda is equal to V over F equal to 3.0 times 10 to the power 8 over F 1.9 times 10 to the power 9, answer will be 0.16 meter. State two reasons why microwave are used for mobile phone, cell phone signals. Actually, This is because it needs short antenna or area, and second thing is it penetrates walls. All mobile phone networks use digital signal to communicate with phones. Describe with aid of a diagram show how a digital signal differs from an analog signal. Okay, digital signal has two values either than 0 or 1. Okay, 0 or 1 is digital, two values only, 0 or 1, while analog has a range of values. Range of values. State two advantage of using signals, digital signals rather than analog. First thing is no noise in digital, and digital transmission is longer and faster. Okay, in this circuit it's a potential divider where all of the resistance, each one of them has a 40 ohm. When switch is open, describe what is meant by potential divider. It divides EMF or potential of battery between two resistors connected in series in proportion to their resistance. So you have to mention these two ideas in your answer. Calculate EMF of battery. Here we still have the switch open, so this branch is not considered in our circuit, and we have only two resistors, and we have known that each one of them have 40 ohm resistance, which means that they are equal. So when reading of voltmeter, which is connected to one of them, is 7.5, this means that the voltage on the other would be 7.5, and this also means that EMF would be 15, which is 7.5 plus 7.5, because the two are connected in series, so potential adds. The switch is closed, and we want to calculate resistance of complete circuit. When the switch is closed, R2 and R3 are connected in parallel, so 1 over R equivalent of them is equal to 1 over R2 plus 1 over R3. Okay, so this means that 1 over R equivalent is equal to 2 over 40. So our equivalent is 20 ohm. Okay, so we can remove these two resistors and represent them by only one resistance, which is 20 ohm. So 20 ohm connected to 40 ohm in series means that the wall resistance will be 60 ohm. Calculate the reading on voltmeter when the switch is closed. When the switch is closed, the potential will be divided between the resistor R1 and resistor R equivalent in proportion to their values. So we can say that V1 over V2 is equal to R1 over R2. Here we have V1 to be 7, V1 we want to know it. V2 is